entire event or want to check back, it will be archived. So welcome to a special live event with PolarTREC to celebrate Antarctica Day. It's with Alex Eilers and the team studying Weddell Seals at McMurdo Station in Antarctica. It's December 2nd here in the U.S., but I know we have folks from all around the world joining us. So thanks for tuning into this event. It should last about an hour. We have a very, very large audience today, so it's probably a good place to type into the chat box if you have questions, and I'll go over that in a second. You should be seeing slides changing on your screen, so I'll give you a little tour of where we are at. We're using the Blackboard Collaborate system, so slides should be on the right. Let us know if you are not seeing one that says kind of a picture of your screen. Blackboard Collaborate. On the left, there is a black screen for my view here, and it's for video. We probably will not be using that throughout the presentation as bandwidth is limited down on the ice. But if you do have a microphone at the end when we have questions, you may be able to use the talk button to speak. You press it down to talk, and then you press it again when you are done. There's a list of participants on the left so you can see who's joined us, and a chat box on the bottom right. At this point, you guys have opportunities to use the chat box. So go ahead and type in your name, the school or institution that you might be at, and then the number of people who are joining you. We'll keep track of the number of folks. Again, the registrations coming in this morning and last night, we are over 3,400 people registered for this event, so it's a big one. So very quickly, before we go on to our presentation, we wanted to mention what is PolarTREC and how did Alex sort of get down to the ice. She'll tell a little of her story as well. PolarTREC is a professional development experience for teachers to head to the Arctic or Antarctic, the polar regions, to study polar science and bring it back into their classrooms. Hopefully they're building a long-term relationship with the research team they work with. And Alex is a great example of that. So she's headed down back with her team this year and working further on the studies. Jumping forward just a little bit for questions, just a reminder, during the presentation you can type your questions into the chat box and we'll do our best to record them and make sure they get asked at the appropriate time. So if Alex is speaking or one of the research teams, if there's a break, maybe I'll jump in and make sure questions get asked, but they might also be typing answers into the chat box, so keep an eye out there. At the end of the presentation, we'll be able to try and use our voice over IP or talking into the microphone. So again, you press the talk button to speak, and then you unclick it when you're done. If you do have a question at the end, you can use the little hand icon to say you guys have a question. With that, it looks like most folks are sharing where they are and how many people they have with them. It's great to see so many excited people out there. And without further ado, I will turn it over to Alex and her team. So Alex, I am turning it to your slide that says Celebrating Antarctica Day and the Weddell Seals 2014.
Hey everyone.
Are you with us on that?
We are thrilled to be a part of this Polar Connect event today. And we are equally thrilled that you guys are able to join us. And I'm so pleasantly surprised we have so many people here today. And especially today as we celebrate Weddell Seals on or near Antarctica Day. Now before we start talking about the seals, I want to highlight Antarctica Day, which actually celebrates the signing of the Antarctic Treaty, which occurred on December 1st, 1959, so almost 55 years ago. And so on that day, 12 nations worked together and set aside 10% of the Earth, the entire continent of Antarctica, to be used for peaceful scientific purposes. And now these nations and more are working together to use science as their global language. So I think in today's day and age, there's a lot to be said for that. So we're very excited to be presenting on Antarctica Day. All right, now where are we? And we are talking to you today from McMurdo Station, Antarctica. And it is one of 3 U.S. stations here in Antarctica. The others are located at the South Pole, so that's near the center of the continent, and Palmer Station, which is located on the peninsula, and they're highlighted in the first picture you see there. So we are at McMurdo Station. Actually, it's not on the continent itself. We are just off the continent on an island in the Ross Sea called the Ross Island. And it is highlighted in the second picture there. And then the third picture is an aerial view of the places that we spend when we're not out on the ice, when we spend our kind of work day. So the labs, Prairie Labs, is located at the bottom picture on the far right. We spend a fair amount of time there, and that's where we are now. The galley, in the center of that bottom picture, that's where we eat. We probably spend too much time there. And then our dorms where we sleep. I've highlighted the dorm, my old dorm when I was here in 2012, and the new dorm. We probably don't spend as much time in those rooms. Okay, well, who are we? Who is on the team? So I'd like to introduce the entire team. There are 6 people on this part of the project, and they are Dr. Jennifer Burns. She is our PI, or Principal Investigator, which means she's the team leader. So she is responsible for the entire project, from the start to the finish. And she will actually be working very closely with our co-PI, Dr. Ward Testa, who is actually not down here for this deployment. And Dr. Greg Frankfurter is our team veterinarian, and he has a big responsibility, about 1,000 pounds big. His job is to sedate the seal, or put them to sleep, and care for the seal while the team is working. And then the next 3 pictures are Michelle Shiro, Roxanne Beltran, and Amy Kirkham. These are the 3 graduate students down here on the project, and these ladies are amazing. They are young, smart, energetic, and excellent in the field. And if you didn't notice, they're all female, so we have a little girl power going on here. And then there's me, and I truly think I've got the best job down here. So I get the pleasure of working with these amazing scientists, and I get the pleasure of sharing what I've learned with all of you. All right, so let me give you a little background. Some of you may remember that I was down here in 2012 working with Dr. Burns on another Weddell Seal project, and it was really an amazing, life-changing experience for me. But one of the most amazing things I witnessed was the scientific process in action. So we were down here gluing satellite tags on the heads of Weddell seals, and Dr. Burns noticed that the seals that we were working with were molting a little later in the season. And she asked the question, she goes, I wonder if these seals that are molting later, she goes, I wonder if they pupped earlier in the season. And so that question sparked the idea for this current research project. So I'd just love to see this science project in action. So now I'm going to turn it over to Dr. Jennifer Burns, who is going to talk a little bit more about our current project.
Do I get to advance the slides, or just you can tell them?
Can you advance? Hello, everybody. I'm Dr. Jennifer Burns. I'm at the University of Alaska Anchorage when I am not down here in the Antarctic. And over the past couple of years, I think this is 4th year running, I've spent about 3 months in the Antarctic and the remaining time back home in Alaska. So I see a lot of snow and ice, and people ask me why I want to come down here during the Antarctic summer. And I say, well, it's yes, there's snow and ice here now, but it is warmer and sunnier here than it is at home right now in Alaska. So it's a good transition for me to get lots and lots of daylight across the year. We are in 24 hours of daylight right now in Antarctica, and back at home in Anchorage, Alaska, we are down to almost 5 hours of daylight a day. So this is much nicer. The last project that we had Alex down with us on was a study of where the Weddell seals were going during the Antarctic winter. So there's previously been a lot of work on Weddell seals looking at what they do during the summer. But scientists like to leave Antarctica and miss the Antarctic winter time, and we didn't want to be here. So instead, we glued instruments onto the head of Weddell seals, like the picture that you can see on the left there. And those instruments provided us with information on where the seals went during the long, dark Antarctic winter. And the image on the right shows the track lines of where the seals were going during the winter. We are way down at the bottom right on that figure, Ross Island, and you can see that the seals were traveling more than 500 kilometers or a 1,000-kilometer round trip during the winter time. If I can have the next slide, one of the things about gluing tags onto seals is that they need to have molted out of their old fur and into their new fur. And in January and February, we walk around the colonies and we look at seals, and some of them are molted, like the seal in that top picture, and that's a nice silver-black seal with good new fur. And some are not molted, like the seal in the bottom right, and that seal you can tell is kind of brown and ratty looking. And what happens is over the year that the seal has its fur, that fur gets exposed to seawater and sunlight, and it just gets kind of worn out. They never get a shower other than in seawater. And so once a year the animals have to molt their fur, shed their fur, and the middle picture shows a seal that's got a new fur showing down its dorsal, down its backbone, and a new spot of fur on its hair. It's in the process of molting or shedding its fur. If you have a fuzzy dog, sometimes your dog sheds and you can see that. Well, for the last project, we had to put tags on animals after they had molted into their new fur coat. And as Alex mentioned, we found that all of the seals that we were putting tags on, gluing onto that nice new fur, all the seals that year had not pupped earlier that year, and we thought that was kind of weird. And so if I could show you the next slide, what we're looking at, what we noticed was that there were links between pupping in one year and whether you molted or when you molted in one year. And if we can look at the next slide, we actually went out and looked at a whole lot of seals, and we found that the probability of a female having given birth to a pup influenced whether or not she was molted when we were looking around the colonies to see if we could find animals to put tags on. The first bar in that graph shows that of the females that had not pupped in a given year, 80% were molted when we were looking at them, as compared to females that had pupped in a given year, when almost 90% of them were not yet molted. So there seemed to be links between pupping, the probability of pupping in one year, and molting in one year. And so that was kind of puzzling because nobody had previously reported that. And so then we also started thinking about, well, what possibility does molting have on pupping the next year? So the next slide shows two different female Weddell seals. One that is a mom in that she's given birth. You can see her cute little fuzzy pup right there. And another female, the one on the bottom left, is what we call a skip female. She has previously in different years given birth, but this year she is skipping reproduction for some reason. And we were interested in whether when the female molted influenced whether or not she came back the next year as a skip female or not a skip female. And the next slide shows the probability of coming back as a mom or a skip female based on whether or not the female was molted when we saw her in year one. And you can see there that the probability of pupping was highest for the females that we saw that were molted in the previous year. So that far left bar graph has the highest probability of producing a pup the next year. And if we saw the females in year one and they were not molted, the bar graph on the far right, that's a little bit lower probability of coming back to pup the next year. So that suggested to us that there were some links between when a female molted in one year and whether or not she produced a pup the next year. And the next slide shows another question that we had, which was whether or not females came back and produced a pup early in the spring or late in the summer the next year. So the timing of when that pupping event occurred. And if we look at the bar graph on the next slide, we can see that the females that were molted when we handled them in January, that's the dark blue in that bar graph, were more likely to produce a pup early in the pupping season, in early October, than they were in November. So females that molted earlier tended to produce a pup the next year a little bit earlier. So that suggested to us that there might be some links between pupping in year 1, when a female molted in year 1, and the chance or probability of when she produced a pup in year 2. So interactions between reproduction and molt. And the next slide kind of shows our overall schematic between our question was whether there were links then between reproduction and molt that we could, by studying seals, understand what was going on. And the linkages between those two events, producing a pup and nursing that pup and making a healthy new Weddell seal, and molting, getting a new fur coat, those are generally likely to be influenced by the condition of the female, how fat and how healthy she is, or hormones that play a role in reproduction or molt. So we have two main drivers or two main factors that might influence this link. And that led us to our research questions, which are on the next slide, with our happy Weddell seal. And the main research questions that we are down here studying right now are around the questions of how do mass, body mass, how much the animal weighs, how their condition, how fat they are, what their hormone levels are, and how much activity budgets of what they do on a day-to-day basis, how much time they spend sleeping or diving or feeding. How do those change between the reproductive period and the molting period in our females that are moms and our females that have decided on a given year not to produce, or our skip females. And our second research question, which is on the next slide, was really when does active gestation start? So when do seals get pregnant, and what factors influence the success of that mom at being able to produce a pup the next year, so pregnancy success. And you've now listened to me sufficiently, and I've got a great team of graduate students down here, so I wanted to share this presentation with some of them. And I'm going to turn this presentation over to Amy Kirkham for a presentation on what we're actually doing down here.
Okay, awesome. Thank you so much, Jen. My name is Amy, and I'm one of the graduate students working on this project. I'm thrilled to be talking to all you guys today about the work that we're doing down here. So I'm the one on the bottom in the middle there. So Jen did a great job of explaining the general scientific questions that we're addressing that are part of this grant. And to actually answer those questions, we need to come all the way down here to Antarctica, and we need to get out in the field to go find these seals so we can take measurements from them and understand more about what's going on in their bodies and through their life histories. So to do that, we go out on the sea ice where these Weddell seals live. And to get out there, we are lucky. We get to go out in snowmobiles. So here you can see a picture of us prepping for day out on the ice, and you can see we each have our own snowmobile. They're yellow, they're easy to see on a landscape that is all white and blue, and we carry all our gear out there in big red sleds, so we drag it all behind us. So every morning before we go out, we have to pack up all our stuff and get ready to travel out. And when I talk about sea ice, that is ice that is just the top layer of frozen ocean. It's about 6 feet thick. So we're driving out on roads that are on top of the frozen Antarctic Ocean. And if you look at the next slide, you'll see exactly where in the Antarctic Ocean we are doing our traveling. So this is a map of McMurdo Sound, and that's a small part of the Ross Sea where our study animals all live. At the bottom of the map, you can see a big star. That's where McMurdo Station is, where we're talking to you from right now. And all the other red dots on this map are seal colonies, where there's lots of Weddell seals that we can go to visit when we're looking for our study animals. And you'll notice most of them are next to islands or along the coastline. That's where big cracks develop in the sea ice, and seals like to hang out where the cracks are because that makes it easier for them to get in and out of the water so they can get food and teach their pups how to swim. Now this is a great place to study seals because the population of seals that lives in all these colonies has been studied for many, many years. They've actually been studied since the 1960s. And almost all the seals that live here have individual flipper tags. So each of those tags has a number, and that number tells us who that animal is. So since we're looking for specific animals, like animals that have pupped or haven't pupped, we can go up to seals and look at the tags that they have, figure out who that animal is, and find out if it's a good study subject for our research questions. So every day we'll get on our snow machines, we'll drive out to one of those colonies, and if you go to the next slide, you will see what we do once we find a seal. So here's a couple pictures of our team working with a seal, and if you look at the left-hand side, you'll see what we first do once we find an animal that we're interested in studying because she matches our criteria, and we figure that out by looking at her flipper tag. We have a net that we use to capture the seal, and Weddell seals are not very shy. They're not scared of people, so it's not very stressful for us to get one in the net so we can handle her. And the next thing we do is we have our veterinarian, Dr. Greg Frankfurter, give her some sedatives, and those are drugs that sort of make her fall asleep for just about 2 hours, and that's just long enough that we're able to get all the samples and measurements we need from her before she wakes up and goes back to taking care of her pup or hunting or molting or whatever else she's doing at this point in the summer. And if you look at the next slide, you'll see some of the very first measurements we take when we're handling a seal or doing a seal procedure. Now one of the things we're most interested in figuring out right away is how much our seal weighs. So these seals are much, much bigger than most of the seals you might see along the edge of the United States. They're very, very heavy, so we can't just pick them up and put them on a scale. We actually have a special scale tripod that was built just for these seals. And in the left-hand picture, you can see that tripod set up. And what we do is we get the seal inside a sling, and then we pick the seal up off the ice. And they're very heavy again, so it takes the whole team to get this done. And then we see how much the seal weighs, and that weight gives us a lot of information about how healthy that animal is, how much blubber it might have to help it keep warm and to give it energy when it's not able to eat very much food. And we see a big range of weights on these animals. So far this year, we've seen seals that weigh anywhere from about 500 pounds to over 1,000 pounds. These are large seals. They're about the size of horses that you might ride. So once we figure out how much the seal weighs, there's other measurements we can also take that show us a little bit more about how healthy they might be and how much energy they've already used up taking care of a pup or doing other things. So in the right-hand picture, you can see a couple of our team members measuring how wide the seal is and how tall the seal is. And by looking at those measurements at different points on the seal's body, we can see exactly how much energy that seal has stored and how healthy it is and how much it's already used up so far that season. So I'm going to pass over the presentation to another graduate student that I'm working with. And so here is Roxanne Beltran. That's okay. Thank you, Amy. Hi, everyone.
Hey, and this is Sarah from PolarTREC. Just real quick, I'll mention there are some great questions coming through the chat box. For folks that are on the phone, just so you know, people are asking pretty basic kind of natural history questions about seals. How big are they? What do they eat? Are they omnivores? That kind of thing. So pretty basic information. And for any teachers out there that are following the presentation but also want that information in the chat box, we should be able to get that chat information to you if you're curious. So I'll send out the archive in a couple of days, and let us know if you'd like a copy of the chat as well. Sorry, Roxanne, didn't mean to interrupt too much. And
so hi everyone, my name is Roxanne. That's me on the bottom left, just getting out of the water from scuba diving in California. I wanted to thank you guys for coming today. We're very excited to be able to talk to you all about the work that we are doing. So Amy gave a great introduction about the first measurements that we take when we start handling a seal. And right after we take the weight and the measurements of the seal, we actually take a few blood samples and tissue samples because the seal's bodies can tell us so many amazing things about them. Here are some pictures of what we take. So if you look on the top right picture, that is a picture of us taking blood from the seals. And the reason we take blood is that we can look at the hormone levels in that blood. And those hormones can tell us a whole lot about which part of the annual cycle the seals are in during a given time. The picture on the top left is us taking a small skin sample. It's about the size of a hole punch. And the skin samples can help us understand where exactly in the molt the seals are. So sometimes they'll actually begin molting before we can see the seals shedding any of their fur. The middle row on the right side is a blubber sample. And we take blubber samples in order to look at their diet. Because their blubber is made up of lots and lots of fats, those fats are specific to the fats that are in the fishes that the seals are eating. And so we can actually use those different kinds of fats to try to figure out what types of fishes the seals are eating. In the middle row on the left side, you can see a small muscle sample. And we look in the muscle to try to figure out how good these animals are at diving. We know that they're really good at diving, so we can actually look at the oxygen carrying capacity of that muscle, which tells us how good they are at diving. On the bottom left, you can see pictures of two whiskers. Whiskers are my favorite tissue. They're really neat because they grow throughout the year. And whenever they grow, they actually record the diet at the time of growth. So if we take one whisker, let's say it grew throughout the entire year, we can actually backtrack and figure out what the animal was eating throughout the entire year and at different parts of the year. So that can give us lots of interesting information about not only where the seals are going, but what they're eating. And then the picture on the bottom right is a picture of fur. And we take some small clipped patches of fur that can tell us a little bit about some of the stress hormones that are in the seals' bodies, which can let us know if they are or not getting enough food or if they're stressed out in their environment. So if you go to the next slide, you'll see that in addition to taking samples, we also put tags on the seals. So like Jen mentioned, because this is during the molt, we have to put all of the tags that we instrument the seals with not glued onto the outsides of their bodies because those tags would just fall off, but we actually put them on the flippers. So it's sort of like getting a little earring, except instead of on their ears, we put them on their flippers. That is a picture of Weddell Seals flippers. You can see the little yellow tags are the tags Amy was talking about that helps us figure out who each of the seals is. And then on the right picture, you can see the different types of tags that we use. So the one on the very left is called a very high frequency tag. That is a small tag that emits a very sharp pinging noise that we can't hear and the animals can't hear, but we do have an antenna that can help us hear the sound of that tag, and so we can use that to relocate the seals throughout the year. The tag on the very right is called a satellite tag, and that can actually tell us where the seals are going in space. So that tag will communicate with satellites, and those satellites can communicate with our computers. So during the summer months in, let's say, December or January, when we're sitting in our offices in Alaska, we actually know where the seals are going. And then the middle tag is called a time depth recorder. And that basically lets us know where the animals are going in the water column. So every 6 seconds, that tag tells us exactly what depth the seals are at.
And we can get lots of really cool information from that tag. So if you go to the next slide, I'll give you a sneak peek of our very exciting dive data that we're getting back from these tags. So on the left side, you can again see a flipper, and you can see that time depth recorder tag that we're putting on the seals. It's about the size of your pinky. And the figure at the top is just the raw dive record. So what you're seeing on the y-axis is depth. So the very top of the graph is the surface, or 0 meters of depth. And then going down to the bottom of the graph is the very deepest depth that that seal was diving throughout a 3-month period. So at the most, that seal was diving about 500 meters, which is about 1,500 feet. So if you look at the ceiling in the room that you're in right now, it's probably about 10 feet high. So imagine 150 rooms stacked up on top of each other, or a 150-story building. That's how deep these animals can dive. And the reason they can do that is that they can hold their breath up to about 90 minutes. So one of the things that we're interested in is this natural clumping of dives. If you look at the bottom figure, that's a very similar dive record where you can see the different colors represent what we call bouts, or groups of dives. And these seals dive in bouts for a lot of different reasons. But those bouts can give us information about how long the animals are spending at the surface, or even what types of prey they might be eating, whether they're eating a schooling fish or a solitary fish. So with all this information, we can basically see what the animals are doing throughout the entire 3 or 4 month summer period. So I'm going to pass it over to Michelle, who will give you guys some information about pregnancy diagnosis that we're doing during the January-February field season.
Hi, so I'm Michelle Shiro on the top right of that picture, and I'm also one of Jen's graduate students from UAA. And what we're looking at in January and February during the molt period is when animals become pregnant. So in the next slide, you'll see we do this with an ultrasound machine, and this allows us to just take pictures and videos about what's going on with really early pregnancy. So we use a transrectal probe, which is done a lot in cows and horses and other livestock species. And this allows us to see really early pregnancy when the baby or embryo is very small. And very few people do this on exotic species or wild animals like Weddell Seals. It's actually never been done in Weddell Seals before this project. So we recruited an expert. In that picture in the top right is Dr. Greg Adams, and he's not with us for this deployment, but he will be down again. And he's done these ultrasound exams in a whole bunch of different species. He's done them in elephants and rhinos, and bison and other seals, and pretty much anything that you can think of. So we can start to look at very early pregnancy with that machine that you see at the bottom left. And we can also track these animals, so we know who was pregnant in January and then who was healthy enough and came back the next year and actually gave birth to a pup. Because all the things that you've been hearing about from Jen and Amy and Roxanne with body condition and hormones and how well these animals are able to forage is going to influence the likelihood of these animals coming back the next year with a pup as well. So the next slide, we have an annual calendar that shows a lot of the really energetically costly parts of a Weddell Seals year. So the idea is in October, November, December, the animals are pupping and breeding, and then in January they're molting. And this is all costing them a lot of energy. So they shouldn't become pregnant for the next year until all these other energetically costly events are over, because pregnancy is also really energetically costly. So we were hoping that when we came down during the period of the annual molt, we would start to see when these embryos are starting to grow. Because Weddell Seals have what's called an embryonic diapause. So the animals are bred, the female's egg is fertilized, and the fertilized egg starts a couple of cell divisions, and it forms what's called a blastocyst, or kind of a pre-embryo. And then it stops growing for a little bit. And in other seal species, this can last for about 4 months, but then at some point, growth has to start again. So we were hoping to catch when this first happens at the end of the molt in January and February. And as you've heard before, Weddell Seals give birth all within about 1 month, when the weather is better, when it's sunny and warmer. So we were thinking that we would come back and find really early pregnancy, and all of the animals would be at a similar stage, and we'd see these very, very tiny little embryos. But what we actually saw was kind of a wide range, and much wider than we had expected. So on the bottom left, you can see a very small embryo, probably a couple days after growth had begun, and that embryo is less than a centimeter in height. And all that is a little fluid-filled spot in the uterus. And then in the middle, in that center image, we can start to see a larger embryo and what's called an embryo proper. You can start to see, maybe you can see a little baby inside that black vesicle. And then finally on the right, we could see a much larger embryo. We could see a heartbeat. You can see kind of the head at the bottom of the image, the hind limbs. And this embryo was actually so far along that we could tell it was probably going to be a male if it was brought to full term and born as a pup the next year. So on the next slide, we have some preliminary data. We've been looking at differences in how large those embryos are between animals that had skipped breeding that year, or they didn't have to deal with nursing a pup, and they were able to save all that energy, versus females that had given birth and were moms. So at the bottom, you see a bar graph, and the skip breeders were much further along, or somewhat further along in their pregnancy, and they had larger embryos as compared to the moms when we did these ultrasound exams. And at the top right, you can see we can build a growth curve for really early pregnancy and how fast those embryos are growing. And we can use these growth curves to sort of backtrack. So we can look at how large an embryo should be just before it starts growing again, or diapause ends and reactivation starts. So we saw that in Weddell Seals, you see on the y-axis we have embryonic vesicle size, and on the x-axis we have how many days after the Weddell seal had given birth. And you see that about less than 2 months after a female gives birth, she starts pregnancy for the next year. And that's right at the end of weaning. So that shows that in Weddell seals, that diapause time might be really, really short, which would be pretty unusual for a seal species like this. So I'm going to pass it off to Alex again.
Okay, so isn't this some amazing stuff? This is what the team has been doing down here, and I am just absolutely thrilled to be a part of it. So at this time, if you guys, I guess, have any questions, should we do that, Janet and Sarah?
That sounds great. So Alex, I just turned off your microphone, so as I'm speaking, people won't hear too much feedback. But thank you so much to the team for that presentation. That was great. There are a lot of questions in the chat box, and so I know the team is working hard to answer those. But at this point, we can open up microphones and let people ask questions live. So if your students or folks with you are ready, they can come right up to your computer or wherever it's set up, or even on the phone, and ask a question. So what we need you to do, if you're interested in asking, is hit that little hand icon over by the participant list, and we'll know that you're ready to ask a question. Then we'll call on you, and you can press the talk button, ask your question, and then press it again when you're done, and the team will be able to answer. So we'll let people kind of get organized a little bit and see if anybody in their classrooms or homes want to ask any questions. Anyone on the phone, you're welcome to just kind of interrupt and chime in if you do have a question. Let us know, because you can't, click on anything on the computer. So it looks like we do have a couple of classrooms ready to ask questions. So Mrs. Robin Lovegren is going to be first. So click your talk button to speak when you're ready. Click it again when you're done, and then the team will be able to use the talk button to answer you. Go ahead, Robin.
Hi, I'm Margaret from St. Louis School, and I was wondering,
What is the most exotic animal you've seen while you were in Antarctica?
Yeah, we're deciding here. There's several.
So in the January-February season, when the sea ice opens up a little bit, sometimes we get whales all the way into station. And this last year, we saw some minke whales, which are baleen whales, up really, really close to station, which was definitely one of the coolest things we've seen. They were right next to us. They even sometimes scared the seals out of the water by coming up right behind them. But they're really cool animals.
Thanks. That was perfect. All right, so Mrs. Garibaldi's third grade class has a question.
Hunter from Memphis, and what's the hottest it's been in Antarctica?
Okay, so the record temperature it's ever been in December in McMurdo Station is 55 degrees Fahrenheit. It hasn't gotten that warm so far this year. This year the warmest temperature was about
30 degrees Fahrenheit. Today it's 21. Nice. Last year we had a bunch of really warm days that were about 35 degrees, which is warm for us.
Thanks. All right, so I am going to move us to Colonial Middle. Looks like they have a question. Go ahead.
Video? Okay. All right, here we go. Yay. Okay, ask the question. What do the researchers eat?
Well,
Okay, go ahead.
The researchers, we actually have our meals prepared for us. We have a cafeteria. So differs day to day. We eat a lot of pizza. There's 24/7 pizza, so when we get in late and miss dinner, we eat pizza. Jen likes to eat sardines in her field lunches. We bring out sandwiches every day. We bring out hot soups and stuff like that. Yeah.
But guess what? There is not here today. And I think I've probably talked to everybody about the Snickers. There's not one Snickers on the base. Not one.
Wow, that is surprising. So we're getting questions from all over the place. I'm going to ask one that is coming in. How does the process of molting work?
Okay, that's a great question. So when seals molt, they shed all of their fur, and they do it all in about 2 months' time. So instead of losing hair kind of all throughout the year like people might or other animals, they compress it in one little bit of time. And they do it by changing the activity states of their skin. So their skin will kind of rest for most of the year. But then during those 2 months, each hair follicle that has a hair growing in it will reactivate, and it'll start getting more nutrients from the blood, and it'll start growing and producing an entirely new piece of hair using protein. And when seals molt, they do it in a pattern along their body. So if you remember when Jen was showing the animal that had molted all the way and the animal that had molted partly, you could see it molted first along its back. So we can actually see how the molt proceeds on the seal's body, starting on the back and then going down the flanks of the animal. And as it goes down those flanks, the skin in each of those spots will start getting those nutrients and growing hairs. And then when it's done, it has entirely new fur everywhere.
And I think that journal about fur and molting was posted, I think, earlier this week, too. So make sure to check the journals, because it goes into a lot more detail of what we're doing now.
Yes, Alex's journals are incredible in explaining, kind of starting with the basics of the seals and then what life is like down there. So if you want to learn more, make sure you check out her journals too. Okay, we're going to go to Tammy Wilson. If you're ready to ask your question, go ahead.
Hi, my name is Kate Vincent from Tammy Wilson's class, and I was wondering, how do seals have babies? Do they have babies like 2, 3, or 4 at the same time, or they just have one like a month or 11 months?
That's a really good question. So Weddell seals only give birth once a year. They give birth in October and November because that's the start of the summer down here in Antarctica, so it's much warmer. It's a good condition to have a baby because you don't want it to be too cold. They only give birth to one pup each year because the females have to nurse those pups for about 6 or 7 weeks. And it costs them a lot of energy, and they actually lose about 1/3 of their body mass. So they can only afford to have one pup each year, and they spend the rest of the year trying to regain all that mass and prepare for the next year.
Thank you.
Great job. Okay, looks like Nicole Nanny is next. People are asking some great questions in the chat as well still, so we can follow along there too.
I'm Connor Middleton from Miss Nanny's class, and I'm 5th grade, and I'm wondering, do grown-up seals eat their young?
No, they do not. So these seals do not have that behavior. That's not something we ever see in marine mammals.
The marine mammals, they'll nurse their pups, and then they teach their little pups how to swim for a little bit, and then moms split, and they just leave the pups to learn how to forage for themselves.
Thank you so much.
Perfect. Let's go to Joanne Pedersen's group there. And just so everybody knows, we do have about 10 more minutes, so lots of questions can keep coming in.
My name is Aiden. Okay. My name is Aiden, and I'm from Lakeland Elementary School. And my question is, what's the coldest temperature the water can be?
I did push down. Am I doing it wrong? Did they hear it?
No, you did it right.
Hi. That's a great question. So the water temperature is actually cold throughout the entire year here. It can get down to about -1.8 degrees Celsius, which is about 27 degrees Fahrenheit. And that's about as cold as water can get without freezing. Because it's so salty, it can get that cold. But for example, fresh water, it would freeze at that temperature. So because it's salt water, it can get down to really, really, really cold temperatures. But luckily, the seals have lots of fat to deal with those temperatures.
Great question. All right, next in line we have Susan.
Hi, I'm Lawson Beaupre, and from Miss Painting's class, first grade, have you found any injured seals with teeth marks in them or like something else?
Hi, that's a really good question. So we have seen some seals that are injured. We're here during the breeding season, so the males are guarding those territories, and sometimes they'll fight with each other underwater, and we see them when they haul back out on the ice with some injuries or bite marks. Yes.
Perfect. Looks like the group with Nicole Naney is ready for
My name
question.
is Owen Cantor, and I'm in Miss Nanny's 5th grade class. Do penguins and seals ever interact?
Hi, Owen. That's a great question. They sometimes interact because they're both in the water column. So at the ice edge, if you look at that picture on the left, you see where the ice and the water meet. That's a really good place for both seals and penguins to enter the water. So sometimes they'll swim around together a little bit there.
And the penguins we've seen are kind of curious. So when we haven't seen any penguins this year, but when we go up to seals, every once in a while we'll have a penguin just kind of waddle up like he's being very curious.
Thank you.
Okay, thanks. Folks are welcome to also continue asking questions live. Put your hand up if you do have a question. And is there anybody on the phone who would like to ask a question live? Just unmute your phone and go ahead and ask. I'll leave you some space for that for a second. All right, folks on the phone, you just interrupt me if you have a question. Some of the questions that are coming in the chat box are talking about how do moms teach their babies?
After the pups are a couple of weeks old, the moms will start to call them into the water, and they go on kind of short little swims. But that's about all they're doing as, for teaching their pups. In a lot of species, they don't teach their pups to start foraging at all, and moms just split.
Okay, I'm also seeing some questions about naming the seals, and I have done, and I think it was last week, kind of an overview of the seals we have worked with so far, which are 16 seals, and we've named some of them, but then there's a couple of them we haven't named. So I would love for you to go to PolarTREC.com and go to that journal and submit some suggestions for those names. So a couple of the names, if I'm remembering correctly, one was Galaxy, one was Skittles, one was Angel. Can't think of any. Oh, Hiccups. That's right. We have one that's Hiccups. But there's a couple of them that we haven't named, so we'd love for your suggestions.
Perfect. Okay,
My name's
looks like Tammy has
why do seals
questions
need
from her group.
molt
Go ahead.
fur?
Okay, so seals need to molt their fur to keep their coat nice and healthy. So if the hair never replaced itself, it would get very, very worn down, and it wouldn't do a good job of all the things that seals need a fur coat for. So the fur does keep them warm when they're outside of the water. It protects their skin when they're swimming, and it makes it so they can swim through the water better, because that surface of having hair on it has a better way of interacting with water so they can swim more easily.
And it also helps them walk around on land. So if you ever see a seal kind of inch along on land like an inchworm, or it sort of looks like a person stuck in a sleeping bag, the way they grip the ground when they're moving that way is using the fur on their belly. So if all that fur wore down, they wouldn't be able to move around as well and stay as warm, and it would make them less healthy overall.
Thank you.
Okay, looks like Joanne Pedersen.
Hello, I'm Priya from
Do you have a
Baker Elementary,
question? Go right
second
ahead.
grade. I was asking, do all seals have the same amount of blubber?
Nope. All seals have different amounts of blubber, and it also depends on the time of the year. So some of the females that we're seeing now that did not have a pup, they have all this fat that they didn't have to use for nursing, so they're really, really fat. The moms we're seeing now have transferred a lot of that energy stored in the fat to their pups. So they have a lot less blubber, about 2 centimeters thick, whereas the really fat ones have about 6 centimeters of blubber. So there's a really big difference between individuals and also at different times of the year when you see them during the molt. Some of them will have gained more blubber, some of them will have lost more blubber.
Thanks. And we are just about getting to the hour. It looks like 2 more folks have questions. I'll turn it over to Nicole, and we'll see how many more questions we can take. Go ahead, Nicole.
Hello, I'm James, and
what did you want to know? You wanted to know how.
I want to know, how do seals survive?
Hi, that's a great question. So seals survive in a variety of different ways. Probably the biggest and best tool that they have is their big fur coat and their big blubber layer. And those two things keep them really warm when it's so cold in Antarctica, both in the air and in the water. One other thing that they do to survive is they're very smart about what they do with their time. So during different times of the years, the seals will either haul out on the ice, so they'll rest, or they'll warm up in the sun, or they'll go and forage and get lots of fish and get nice and fat for those cold winter months. And so because they can change those behaviors, they can sort of cope with the really cold and really extreme conditions that are present in Antarctica throughout the year.
Thank you.
Thanks. So we'll jump back to questions in a second if the team has a few more minutes to stay on. I know some people were interested to see if video was going to work. Alex, do you think you guys could turn on your video and wave? Do you think it would work?
So we've got it on. I don't know if you can see us.
Oh, there we are. Might be slowly coming in.
Well, we got a little bit of a lag time here. Wow. Yeah, it's not updating the picture, but you just look like you've got about a snapshot.
It is a delay, but
awesome.
We see you. I bet you're going to
we
wave in a few seconds.
We are so thankful and grateful that you guys all joined in today, and we just appreciate you. Make sure to follow those journals, because we're answering a lot of the questions in the journals, and there's also video, so we can upload video on the journals. So we've got there's going to be a cute pup one coming on Friday. There's the nose one, that's amazing. We've got a mom and pup nursing that actually posted, I think, a couple of days ago. We've got a lot of videos out there for you guys.
Great. So we saw just a corner of Alex a minute ago, but I think it's a very delayed video, but thanks for sharing it. So we have events coming up. We have an event from McMurdo once again next week on the 12th of December with Lucy. She is going to be talking to us about her project in Antarctica. So we encourage you to join us then, and the archive for this event will go out to all participants and registrants, so we'll send that out. And if the team has time for one more question while folks are signing off, looks like C. Douglas has a question.
Second grade class, and I want to know what was your most exciting thing about your trip.
Discussing that one because that's a really hard question. But I think we've come up with one.
Oh, this is Amy. I think one of the most exciting experiences I had was the very first time I went to a Weddell Seal colony and I heard the sounds that Weddell Seals make. So adult Weddell Seals, and especially the males, can make noises that sound like spaceships or lasers, and you can hear them from underneath the ice that you're walking on, vocalizing deep in the ocean. So it was really, really cool to be walking out on the ice and hearing those very strange noises coming from the animals that we're studying.
And so like every subject we've talked about so far, next week we are planning to post a journal about sounds. You'll be able to hear some of those things that we are hearing.
That is very exciting. Thank you so much to the team. This has been a great webinar. Thanks to everybody for joining us for this Polar Connect event. Again, the archive will come soon. Happy Antarctica Day, and keep up with Alex and the team's posts. They have been great. We will leave. I'm going to stop the